Namaste. Welcome to PABSON Distant Learning Education Program, live in Janata Television. And this class is grade 9 science. And we will continue from previous class that we have discussed previously, the force and motion. So we will continue the class with this force and the motion. So before starting, let's quickly revise what we have learned in previous class. Okay. So in the previous class, we have discussed force and some effect of force also we have discussed on that previous class. Similarly, balanced force and the unbalanced force that we have discussed. We have discussed about the rest and motion also. And for defining the rest and motions, we have defined the reference point also that we've discussed in previous class, and similarly the vector quantity and the scalar quantity that we have discussed in previous class, and the distance and displacement also we have discussed in the previous class. So today we will start the speed about the velocity that we will discuss today. So let's start with the speed. Okay, speed. Speed, it can be defined as the distance per unit time. That is the speed, right? Distance per unit time, or the distance covered in the certain durations of time, can be defined as the distance of a body, right? And the distance, speed of the body, and the speed, the unit of the speed, SI unit of the speed is meter per second. And in the CGS system of unit, we can measure this in centimeter per second also. SI unit is meter per second, and the CGS system of unit we can measure with the help of this centimeter per second. And this speed, it belongs to the distance, which is the scalar quantity. That's why the speed also the scalar quantity. Okay, and we can write down the formula for the speed. Speed can be calculated by the distance covered by time taken. So unit of this distance covered is meter, and the time taken is second. So its SI system of unit is the meter per second. And the speed, there is two kind of speed is there. One is called the uniform speed, and another is called the non-uniform speed. Uniform speed means if the equal distance is covered in the equal interval of time, then that is called the uniform speed. And if the unequal distance is covered in the equal interval of time, then that is called the non-uniform speed. Okay. And next term is we have velocity. The velocity. Okay, velocity. The displacement per unit time is called the velocity. That means displacement covered in the certain durations of time can be defined as the displacement. And this velocity. And this velocity, its SI unit of velocity is meter per second. And this velocity depend upon the displacement, which is the vector quantity. That's why this velocity also the vector quantity. Being it depend upon the displacement, which is the vector quantity, so the velocity also the vector quantity. So we measure this in meter per second in the SI system of unit, whereas centimeter per second also we can use on the CGS system of unit. So let's write down the formula for this. Velocity equals to displacement divided by time taken. Okay, so this one is displacement divided by the time taken is the formula for this velocity. And this displacement, it is measured in the meter, and the time taken, it is measured in the second. That's why the SI unit is the meter per second for measuring this velocity one. Okay. Okay, and also we can write down this distance covered in the certain direction. Okay, displacement also we can write down, and we can also write down the distance covered in the certain direction is also the formula for the velocity one. So let's try the one numerical problem for calculating the velocity. So question I have given in the screen. So there is one question is there. So let me read the questions. A car traveled 100 kilometer in the 50-minute time towards the east. Then calculate the velocity of a car. So how to solve this? Let's see. So solution. The given there is the distance is given over there, right? Distance covered, that is S will represent, right? And it is given 100 kilometer. Okay, it is not in SI system of unit, so we'll change this into the SI system of unit. How to change? So 100 is there, and we know 1 kilometer equals to 1000 meter. That's why to change this kilometer into meter, we need to multiply by 1000. That we have discussed in the measurement chapter also. So multiply by 1000, right? Now it is meter. Why? Because, okay. So this reason you can write down, because 1 kilometer equals to 1000 meter you can write down. Okay. So this one is 1, 2, 3, 4, 5 meter. Okay. And time taken also given over there. Time taken. So I will write down this T. There is given the 50 minutes, right? 50 minutes is there, time taken. So we will change this also in SI system of unit. Okay, that is 50 into, okay, 1 minute equals to 60 seconds. That's why we need to multiply by 60. Okay, this one is 3000 seconds. Okay, that is. Now we need to calculate the velocity. So velocity V equals to what? So we have the formula. We have V equals to S by T, right? Velocity is displacement by time taken, or distance covered in the certain direction by the time. This is the formula. So we have the value from there. That is 1, 2, 3, 4, 5. That is 50 is there, divided by the time taken is 3, 1, 2, 3. So let's simplify this. 1, 0, 1, 0 cancel. This 3 zeros cancel. So this gives the 100 by 3. Now velocity, it is a meter per second. That's why it's a meter per second. Therefore, the velocity of the car, so conclusion you can write down. Therefore, the velocity of car is 100 by 3 meter per second towards the east, because in the question the direction is mentioned over there. So we'll write down this towards east. So like this we can calculate the velocity of a moving object. Okay. Okay, so this velocity also, there is two type of velocity is there. One is called the uniform velocity, and next is called the non-uniform velocity. So you can see on the screen there is a one picture is there, right, to explain the uniform velocity. So what this uniform velocity is, in the picture you can see there the 30 kilometer distance is covered by the car within the 0.5 hour, that is half hour, right? Similarly, from point 1 to point 2 also the 30 kilometer distance is traveled within the half hour, right? And from point 2 to point 3 it covers the same 30 kilometer distance about the 0.5 hour. That means the equal interval of equal distance is covered, yeah, equal displacement is covered in the equal interval of time. That's why this is called the uniform velocity. So uniform velocity can be defined as the equal displacement is covered on the equal interval of time, which is called the uniform velocity. Okay. And next, non-uniform velocity is there. Non-uniform velocity means if the unequal displacement is covered in the equal interval of time, then that is known as the non-uniform velocity. Once again, if the unequal displacement is covered in the equal interval of time, then that velocity is called the non-uniform velocity. So this is the definitions of uniform velocity and the non-uniform velocity. Okay, and this velocity, especially in our daily life, the velocity is variable one, right? The velocity is not uniform. Generally, the velocity is non-uniform one. That's why sometimes if the two velocities are given, in that condition, if we need to find the single velocity, that is average velocity, then the average velocity can be calculated by, so average velocity can be calculated by the initial velocity plus final velocity divided by 2. That means average velocity is simply the arithmetic mean of the two velocity. Okay, average velocity is the arithmetic mean of the two velocity, that is the initial velocity and the final velocity. That is about this velocity one. So next term we have is acceleration. Okay, next one is acceleration is there. So what is this acceleration? Let's see. Okay, so let's say one moving object is there. Okay, its initial velocity is 0 meter per second. Let's say, okay, initial velocity is 0 meter per second at the A. Let's say in 1 second its velocity is 5 meter per second. This is on point B. Similarly, when it reaches on the point C, again the velocity is 10 meter per second. Then there is a continuously 5 meter per second is get changed one, right? This rate of change of velocity is defined as the acceleration. That means the increment in the velocity or the decrement in the velocity, that per unit time is defined as this acceleration. So acceleration can be defined as the rate of change of velocity. That is the acceleration one. And the symbol for acceleration we will write down with the help of this A. The small a, that is the symbol for representing this acceleration. So let's write down the formula for this acceleration. This acceleration is change in velocity by time taken. So let's check what is the unit of this acceleration. Change in velocity, velocity unit is meter per second and the time unit is second. So if you change this, then we will get this meter per second square. So this meter per second square is the unit for the acceleration. Okay, the meter per second square is the unit for the acceleration. Now let me derive this from this one, another formula. Change in velocity, if there is a two velocities are given, let's say initial velocity is given, final velocity is given, then what will be this change in velocity? So change in velocity mean generally final velocity minus initial velocity divided by this time taken. Okay, and this final velocity, the representation for this final velocity is v and initial velocity is u by t. So acceleration formula this v minus u by t also. If the initial velocity is given and if the final velocity is given, then the formula can be mentioned as a equals to v minus u by t. Okay, so this is the acceleration one. So rate of change in velocity, it is called the acceleration. Sometimes if the velocity get decreased one, that is also acceleration, but there is a special terms is there for that decreasing acceleration, which is called the retardation or negative acceleration. The rate of decrease in the velocity per unit time is called the retardation or the negative acceleration. And this retardation, it is represented by minus a. Retardation, it is represented by minus a. So that it is also called the negative acceleration also it is called. Okay. Okay, so let me draw the one graph for explaining this acceleration. Suppose this is velocity time graph is there. This one is velocity and this one is the time. Okay, so the graph I will make like this, let's say. So this one is the velocity time graph. Let's say this is origin O, this is point A, this is point B, and this is point C, let's say. Okay, now this is velocity. So this one is time interval is there, and this one is velocity is there. So what this acceleration will be there from 0 to A. What I mean is, when the object is moved from 0 to A, then the acceleration will be positive. Why? Because as the time increase, the velocity also get increase one. That's why it is the positive acceleration when the object move from A to B. And if the object move from B to B, that means this one is velocity, right? So from A to B, the velocity is similar one. The constant velocity is there. Initial velocity also same, and the final velocity also same. In this condition, the acceleration is 0, right? Why the acceleration is 0? Initial velocity also same, and the final velocity is same. In that condition, the acceleration is 0. That means if the uniform velocity is there, then in that condition, the acceleration is 0. And another condition for this acceleration, 0 acceleration, is if the object is at the rest. In that condition also, no change in velocity is there. In that condition also, acceleration will be 0, right? Similarly, if the velocity get decreased, for example, from B to C, the velocity get decreased as the time interval increase. And in this condition, the acceleration get decreased one. That is a negative acceleration or retardation, it is called. That means if the velocity increase, it's a positive acceleration. If the velocity constant, that is the 0 acceleration, right? And if the velocity get decreased, then that is called the retardation. So let me give the example for this retardation. Suppose the car is moving. So for retardation, so how it is negative, let's see. So suppose the car is moving with the 20 meter per second velocity. Okay, the car is moving with the 20 meter per second velocity, means it is a initial velocity. So here, initial velocity u, we will represent the initial velocity by the u, that is 20 meter per second. It's a initial velocity, right? If we apply the brake on the car, then finally it comes in the rest, isn't it? That means v equals to 0 meter per second. That I'm giving the example for the retardation. Okay, retardation means decreasing in the velocity. Let's say the time taken for this one is 4 seconds, let's say. Okay, now let's calculate the acceleration for this one. We have acceleration equals to v minus u by t, right? V is there 0, minus u is there 20, and this one is there 4. So this one is minus 5 meter per second square. So look at here, the acceleration is negative here. That's why we will mention here minus a, which is the retardation, equals to 5 meter per second square. That's why if there is a decrement in the velocity is there, then that is the retardation, and retardation is represented by the negative minus e. That is the retardation. Okay, so this is about the retardations and the acceleration. Okay, and the 0 acceleration means if the acceleration of a body is 0, that is simply known as the 0 acceleration. And I've already said the condition for this 0 acceleration, either the velocity should be constant, right, or either the object should be rest. In that two condition, the 0 acceleration is there. Okay, so let's solve some numerical problem belongs to this acceleration. Okay, the question you can see on the screen also. A car is moving with the speed of 36 km per hour. Its acceleration, it accelerates to a velocity of 90 km per hour in the 5 seconds. Then calculate the acceleration produced in the car. So let's check how to solve this one. So here, so I'll write down this number 1 here. Okay, what is given over there? The speed is given, right? So that we will write down as a initial velocity. Okay, so initial velocity. We can write down the speed also. If that is on the same direction, then we can write down the speed. So initial velocity will represent by u. It is given 36 kilometer per hour, right? This kilometer per hour is there. It is not SI system of unit, so we need to change that into the SI system of unit. So how to change? We have learned in previous class also. This is 36. So 36 is there, kilometer is there. That kilometer change into the meter by multiplying by 1000. This kilometer we have changed it to meter by multiplying by 1000. Now this is meter, right? Divided by hour is there. Hour change into minute when we multiply by 60, right? Similarly, that minute will convert into the second, again multiply by 60. That is 60, right? So let's simplify this. Now this is second, isn't it, right? So let's simplify this. 0 0 cancel, this 0 and this 0 also can be cancelled. 6 1 6 6 6 36, right? And 6 1 6 and 6 1 6. That means it is a 10 meter per second. So this kilometer per hour is there, that we need to change into the meter per second. So by this method we can change that into meter per second. So this is initial velocity is given, right? Now final velocity is there. Final velocity also given over there. Symbol for this one is v. This is u and this one is v. So it is given 90 kilometer per hour. That is 90 kilometer per hour. So let's change this also by the same method. That is 90 multiplied by 1000. Now it is meter, right? Divided by 60 into 60. Okay. So this 0 and this 0 cancel, 0 and 0 cancel, right? And we can cancel this 6 by 3 2s are 6 and 3 30. 3 3s are and 0 is as it is, right? Similarly, this one is 2 1 2 and 2 15, right? And this 3 2 and this one is 3 5, right? 2 1 2 and this is 2 5. That is 25 meter per second. So you can see this one, right? 5 into 5, 25 meter per second when we change that into the SI system of unit. And time interval also given over there. So time taken, so represent by t, is given 5 seconds, right? 5 seconds is given over there. We need to calculate the acceleration. So acceleration A equals to what? So what is the formula? We have the formula A equals to v minus u by t. This is the formula for the acceleration. Let's put the value from above. V is here, that is 25, and u is 10 divided by 5 seconds is there. So if you simplify this, is 15 by 5 and 5 3. So this is 3 meter per second square. Therefore, the accelerations of the car is 3 meter per second square. You can write down the conclusion with the words also. Okay, so by this process we can solve the numerical. Similarly, there is another one example is there. Let's solve that also. A bus is moving with the speed of 54 kilometer per hour. On applying the brakes, it comes in rest in 3 seconds. Then calculate the acceleration. So let's see how to solve that one. Okay, that is number 2, right? And initial velocity is given over there 54 kilometer per hour. So here initial velocity. So a symbol for this one is u. It is 54 kilometer per hour is there. 54 kilometer per hour is there, right? Now after applying the brakes, the vehicle come in the rest. The bus comes in the rest, mean the final velocity is 0 meter per second, right? Why? Because the bus comes in the rest, right? So the final velocity is final velocity. So this is v equals to 0 meter per second. So there is given the time interval also there, time taken. So I will represent this by t is 3 second is there, 3 second is there, right? Then acceleration, actually this is the retardation, so let's simplify, then we will represent, okay, equals to what? Okay, so again there is kilometer per hour is there. Let's change this into the meter per second. That is 54 into 1000 divided by 60 into 60. So this and this cancel again. So this one is 616 and 69, right? And this 3 2s are 6 and 3 3 and 2 1 2 2 5. So this one is 15 meter per second. Okay, this one is 15 meter per second is there. Now we need to calculate this acceleration. So we have the formula. We have acceleration equals to v minus u by t, right? So let's put the value. A equals to v is 0, u is 15, time is 3 seconds is there, right? That means this one is acceleration equals to minus 15 by 3, that is 5. Therefore acceleration equals to minus 5 meter per second square. That means we'll write down this minus a equals to 5 meter per second square. So it is the retardation equals to 5 meter per second square. So in this way we can solve this kind of numerical problem also. Okay, and one more numerical problem is there. A bus start from the rest. So what will be the initial velocity for this one? So let me draw this only, okay, for this question number 3. Okay, this is question number 3. So let's read the question. A bus start from the rest. If the accelerations of bus is 0.5 meters square, then calculate the final velocity at the end of the 2 minutes. Okay, so initial velocity is given because the bus start from the rest. That's why initial velocity is 0 meter per second. Why? Because the bus start from the rest. Okay, and we need to calculate the final velocity. Okay, let me write down here the final velocity. While you solve, you write down this whatever you have to calculate at the last. Okay, but I am writing here because it is already written over there, and acceleration is given over there. This one is 0.5 meter per second square is given, acceleration is given, right? And the time taken also given over there. There is 2 minute time is there, 2 minute time is there, right? Then we need to find this final velocity, right? So here is given 2 minutes, which is not SI system of unit. That's why we need to change this into the SI system of unit. That is 2 into 60. Now it is second. That is 120 second. So let's calculate. The formula is same, that a equals to v minus u by t, right? Acceleration we have 0.5. Final velocity v is, we need to calculate. Initial velocity is given 0. Time is given 120 seconds. So if you simplify this, the 120, let me calculate this. Okay, 120 into 0.5, it gives about 60. So 60 equals to v. Therefore final velocity v equals to 60. What is the unit? It is a meter per second. So final velocity is 60 meter per second. So by this method we can solve the numerical problem related to the acceleration. Okay, okay, so there is given the one questions in the screen, so you can check on the screen also, right? This we have discussed previously also. So once you glance over there, there is given the velocity time graph, right? And some questions also there. So questions I will read. you can check yourself. The answer you can remember yourself, because we have discussed this previously also. So what is the velocity of a car at the point B, at the point C, and the D? So there is given the value also on the graph. You can check over there. Okay, and similarly, the accelerations while moving the object from A to B, that also we have discussed previously, so you can remember, right? And similarly, the retardation from C to D also we can calculate, and also we can say also from there, right? And the accelerations from B to C. Okay, you can know the acceleration from B to C also. Generally the velocity is constant, that's why the acceleration is 0 from B to C. Okay, so this graph, velocity time graph, that we have discussed previously also, that's why you can check this and you can remember. Okay, now next thing, we need to discuss the equations of motion, from which the lots of numerical problem will ask one, but this one we will discuss on the next class. Today we have discussed about the acceleration, speed, and the velocity one. So in next upcoming days we may discuss about these equations of motion. So thank you very much for joining. Thank you very much, everyone.